Namaskaram everyone, welcome back to the 79th episode of Master Unreal series, and this one you will love it if you have followed the gameplay tag manager and the base attributes and the gameplay effects. So we are going to enhance these systems, and more importantly we have developed our ability system component, so it's time to plug our attributes in that system. And we will be considering the Sekiro's health system and the buff and debuff mechanics to develop our health system. Okay, I'll first explain the theoretical aspect and then we will implement it in the code base. And if you haven't seen my series and especially the last few episodes, then I highly recommend, because otherwise it will be really hard for you to follow what's going on in the game. Okay, so let's get started. All right, so do you remember this slide? So let me just recall for those who are following my series. You remember we started C++ with the gameplay attributes, and then we added the gameplay ability system in the player pawn, that is your character. And later as we progressed, we came up with the final stable architecture where we decided that the ability system component will live on the player state, which means it will be the owner, and the physical representation will be the pawn. Okay, so that means the ability system component is on the player state. That means your attribute sets will live on the player state. And now based on this information, let me get this one thing clear, that we will derive a base attribute set class in C++. As usual, like we are doing in every situation, we are deriving a base class, and from there onwards we are defining the child classes as per our design and the game. So in this situation as well, you will create a base class, and from there you will derive all sort of attributes, be it your health set, stamina, mana, combat, all kind of attributes that you want to have, which can be influenced by the abilities and effects, will be derived from this base attribute set. Okay, so two things you should know: that there are certain attributes that are must, like for example health is something that every AI character should have, including our player as well. So we will hard code it in the player state. Okay, now if something is on top of that, for example combat attribute set, now not every AI is going to fight, they're just going to participate in the gameplay environment, but not every particular AI NPC will have the combat set. So in such cases, we already have the pawn data, so we will give an option to apply the gameplay attributes. Now it's not just limited to your NPCs, it's also connected with the player. Let's say if you are developing some kind of multiplayer game or a shooter game, or not a story based game, but more of a where you have different type of maps and modes where you apply different kind of features, different kind of experience. In that situation you will not require all the attribute sets, right? So in such cases we will make an option available in the pawn data so that you can add and remove the attribute sets that you want for that level. Okay, so we are going to divide this attributes into two layers. First, which are must have, mandatory, they will go in the player state, and whatever is optional or removable will go to the pawn data. Cool. So let's hit AAA now. As I mentioned in the title and the description, we are going to develop the health system first, because that is the most crucial part for us right now. And we have already done a basic implementation of how to do health and damage in the starting. Now I'm going to show you how you can scale it further to have something like Sekiro or any Soul game that you like. Okay, so I'm considering Sekiro, the shadows die twice. I'm considering this game to explain and draw out the system. So let's have a look. You all know that this game has a lot of buffs and debuffs. For example, poison, burn, fear, right? And we can also consider some effects from other games like chill, like when you get ice attack or a cold attack you get chills, or you can say stun, or you can feel dizzy, bleeding. Let's say you are hit with a sword, then you get a bleeding. Then we have some other effects which are like physical damage, energy damage, electrical damage. Like this you have different type of damages or debuffs. Okay, so I'll consider these four. Okay, so let's say burn, poison, chill and bleed. Now I want you to think what's common in them. To understand how to design your health system, first you need to have what kind of effects you will have in your game that will influence your health, or I must say that will modify your health, right? So in this situation, they all decrease health. I am particularly saying decrease, okay? So that means it's one form of a damage, just like a sword attack you, or you got hit by a car, or you get hit by a physical object. So it's a kind of a damage. Now, how that damage will affect you, in what way it will affect you, will be decided by the logic that you will write. So let me come back. What we did last time was we created a simple damage and a heal effect where we were adding a modifier in which we were considering the health attribute, okay, and then we were adding and subtracting the values. So there was a magnitude that you can set. So for example, if you want to apply a damage of, let's say, 20 or 25, you will set that magnitude. And since you have written here that the magnitude will be set by the caller, like for example, if an enemy is hitting you with the sword, then he can set whatever the damage has to be applied. Or let's say if you go into a fire, then the fire element will decide how much amount of damage should be applied. So this was the simple approach for a very simple game, or I must say, who do not want to go into too much of gas, or you do not want to have a lot of different kind of calculations. And I think I also got a comment like how we will deal with the calculations of armor, resistance and all that. So now I'm considering that, okay? So when you are applying a gameplay effect, you are basically trying to manipulate the attribute's value. So in the previous episode where we designed this health and the damage attribute, we were using modifiers, okay? Now, why this modifiers approach will not work in a health system, let's understand that. Because to scale up, you need to understand the limitations of these. So let's have a look. Ultimately, my goal is to tell you about the executions option. Okay, this is what will help you to get the setup to support debuffs and buffs and resistance. Okay, but to understand that, let's take an example. Let's say you get hit by a sword that is a physical strike on you. So you got a direct hit, which is a physical damage, and it reduced your health by 20 HP. Or let's say it will reduce the health by 20 HP, right? Now let's say it was a burning sword, some kind of design you have that where your sword is having a fire on it. So along with this, you got a burn that lasts for 5 seconds, and every second it will consume 10 HP. Let's make it more interesting. You are fighting with the enemy who has a sword and it hit you, and that sword had a flame on it which created a burn. And now let's say it threw a bomb or some sort of normal thing that created poison around you, and now that poison debuff is applied on you, which will last for 3 seconds if you are not in that zone. Like, you got affected, then you got out. So it will last for 3 seconds, and every second it will drain 8 HP per second. Now, if you remember the fight with the owl in the Sekiro, he used to throw bomb, and you used to get poisoned, and there were some HP reductions. So I'm considering that. So there are two things happening. First, you got hit by a flaming sword which created a burn, and it also gave you a form of physical damage. And on top of that, the enemy threw a poison, and it created this debuff of 8 HP per second for 3 seconds. Now let's say, to counter the player, you drank the potion to reduce the burn, and let's say you drank a potion which gives you 80% resistance. Now with this potion, this 10 will become 2, okay? Then let's say you wore an armor to have a 95% resistance from the physical damage. Right now you are getting your health minus 20 whenever sword hits. So let's say after wearing this armor, this reduced up to 95%. Okay, so these are the two actions that you have taken. Now see, what is happening here is that one single attribute is affected by different type of effects, but the common thing between them is they all come under a damage category. Okay, so now the problem is, if we go with the modifiers approach, then you will not be able to consider the resistance in mind. Anyone can give any amount of damage to you, to your health basically. And I'm not even saying damage, you are basically saying that any gameplay effect can reduce my health up to whatever number they want. Doesn't matter what kind of buffs I have. So that is the problem. There is no resistance calculation right now. Second, anyone can change the health value, which is not good because health is something that is affected by different form of gameplay situations. So that means I need a separate component that will take all the damage into account and will do the calculations based on the buffs and the resistance that I'm having. Right now, I drank a potion that will reduce the burn to 80%. Let's say I drank another potion that completely removes my poison up to 100%. So as long as that effect lasts, I will not get poisoned. Right? So all that calculation is missing. That there is no space to do that calculation. So the execution will provide you that. Okay. So let me tell you what will happen when the burn effect damage is applied. Earlier you used to subtract from the health. Now what will happen? We will take that damage into the account. Let's say it is giving 10 HP and it will apply every second. So this effect will be called 3 times. So let's say every time we say damage amount is equals to 10, then we check whether we have any burn resistance effect on us or not. It's a buff we are looking for. This is a debuff effect. Now we are having a buff. Okay. So if you have such tag on you, or if you have that much amount on you, we can check in the ability system component. You will take that number. In total, what is the resistance to the burn? So we will only consider the 20% damage, 80% will be nullified. So out of 10, you will only get minus 2 HP per second. Okay. So the final damage that will be applied by this burn will be 2. Okay. So right now you have just calculated the amount of damage. Now this was just burn effect. Now we will process for the poison effect. Now there can be lot of damages: burn, poison, bleed, lightning, stun, dizziness, lot of damages. So in such situations, you cannot put everything in a one calculation function. So in such situation, what I recommend is group them further. That means, let's say if it's a burn or a chill, these are elemental damages. So create one calculation function that only calculates the damage for the elemental aspects. Another calculation function that takes all the mind damages in the account. Another function that takes physical damages into the account. Another one can take energy damages into the account. Do not put everything in one calculation. That is what I mean. Okay. So you are not supposed to create one calculation function for each of the effects, but you are also not supposed to put everything in the one function. So group them, use some basic sense to group your gameplay effects, calculations, and then proceed. So right now, burn and poison are two different categories. So you can create two different calculation function, or if you have just 4 to 5 effects in your game, then you can do it in the one function. Okay, so I'll be doing it in a one function to explain. Then in the later episodes, we will split them further. Okay, so I will say burn, chill, and the poison maybe. We will consider these three in a single function. And how it will work: first you will calculate the burn effect damage, then you will go for chill effect damage, then you will go for poison effect damage, and then the final damage will be added up. And then the health attribute will be informed, and then it will subtract the damage. So what you are doing, you are modifying or manipulating the damage attribute. You are not manipulating the health. See, I clearly said what do they have in common? They are all form of damages. Let's say there is a special kind of energy sword that drains your stamina. Now you cannot consider that in the damage. You can consider it in a drainage gameplay effect. Why I'm saying that is because let's say the sword is draining the stamina. It's an energy sword. Let's say you are running or swimming, then in that case also the draining will happen. So you will group those drainages in one calculation. Okay, although the sword attack was a kind of damage, but it is not damaging your health, so you will not club them. Okay, so that's what I'm saying, that first of all look at the gameplay effect, what exactly it is representing, and then based on that you group, and exactly based on that you should create components. Okay, so let's first do this much because I think there is a lot of explanation still required, but I think it will be more beneficial and will be easy to understand once you will code along. Okay, so for this episode, let's first set up the attributes. Then we will see how we will handle the effects. Okay, so like I said, player state owns our ability system component, and this is our owner. Okay, now I want you to observe one thing. The starting episode of C++, I created this character base attribute set. Remember, you made getter, setter, and initer for each attribute. That means getting the value, setting the value, and initializing the value of the attribute, right? Okay, and there was a property getter that was for getting the reference or the property reference of this particular attribute, right? Now this was the attribute, and there was this function of post gameplay effect. So whenever a gameplay effect used to be applied, we used to check if it's applied on the health. That means the modification that has been done, is it on health? If it is, then we used to check and clamp and update the value, right? And we also used to initialize them here. And if we go to our base character, we used to create the attribute set and we used to add that attribute in the ability system component. So this is the starting phase. Whoever is the owner of ability system component, the ability system will automatically scan the attributes that are present in its owner. The ability system component is initialized and it's the player state who owns it. So it will scan the attributes variables that you will create here and it will automatically pick it up. Okay, so that is a small information that I wanted to give. So let's create the base attribute set class first. Okay, so let's go in tools, new C++ class, search for attribute set, create base attribute set. You can name whatever game name you want to give instead of base. Open your ability system into this folder, create a folder for attributes. Open it up, select it, create it. Okay, reload. Now remember, whenever you create an attribute, you have to create the initer, getter, setter, and property getter, just like you did in the base character.cpp. Not the base game character, the base character.cpp. Once we are done with the attributes, we will remove these 4 files which we created in the start. So if I go to character base attributes.h, you used to write this. Okay, so I have explained all this. You can check out that episode. Now I'll simplify it here. So whatever attributes from now on you will derive from this class will automatically have it. So what you will write is define attribute accessors. Then you need the class name, the property name, and now you can write these 4. So I'll just go in the and copy it, paste it here. Do put this oblique. Okay, so this is your class name. So write class name, and this is your property name. So write the property name. All right, so this is your base attribute class. Now let's derive the health set. So I'll go in tools again and new C++ and search for base attribute set. And we will create our first attribute set, that is health. I'll just say health set. Okay, select the folder, open the ability system, attributes, create the class. All right, so now let's define the attributes that this set is going to have. So I'm going to first of all go for a private space. First, what I want is the health. So f gameplay attribute health. Oh, gameplay attribute data, my bad. And I'm going to expose this to blueprints. Now remember, you cannot expose private variables just by typing blueprint read write only. You have to go for U property, blueprint read only. First of all, I want this to be read only. If you want to modify, then you have to call our functions. And let's give it a category is equals to health. And here you have to use something called as meta. In this meta, you will say allow private access. Now this will be exposed in the blueprints. Earlier, so far, we have been exposing protected and public variables, but to expose the private variables in the blueprints, you have to write allow private access in the meta. Okay, so I will create one more attribute data, that is your max health. All right, so as per our presentation, I told you are not going to touch the health directly. You will calculate the damage every second, or basically whenever the effect is applied, you will calculate the damage and then you will send it to the health attribute and then you will do the math. So first you will calculate all the damage that has been applied by the gameplay effect, and that damage or the final accumulated damage will be reduced from the health. Okay, so that means we are not allowing modifiers or the calculations to touch the health attribute. Instead, for them we will create a damage attribute. Now this same system can be applied for healing. Okay, so let's say there is a gun. If I shoot at you or the ally shoot at you, you get healed, or you consume a plant, or you stand in a zone, or you consume some food. All that will give you the healing, and it can happen like you are in a restore zone and you are also eating things which are, so both of them are increasing your health. So in such cases, that healing calculation will also be done by the calculation function. So for that, again, we are not allowing them to modify the health. We will give them another attribute data where this calculation will be done, and we will call it healing. Okay, so they are exactly the same. Okay, so the system or the pattern is same for both of them. I'll do for damage, and then you will do it for your healable use cases by yourself as an exercise. But don't worry, in the later episodes, I will cover healing. But this is just to give you ground to practice. For now, let's say these are the attributes that will be stored in the health attribute set. So I'll go to base player state.h, and like I said in the presentation, all the must have attribute set will be created like this. So T object pointer, you will hold the reference of them. So we need the class. So it's a constant and it's called U health set. Same name as you gave to your attribute set, and I will name this variable health set. Okay, and now when you go to base player state, you are creating your ability system component here. You will also create the object of health set. Remember how we did here in the character? Create default sub object. You are going to do the same thing. So create default sub object. You provided the class, then you give it the name. So that is your health set. Now we have to include its class. So include health set.h. Okay, so you have created the health set. Now what we did earlier was, like in the character file, if you go, we created this BP on health change event. Remember when the begin play used to happen, you go and get the health attribute and get the change delicate, then you used to bind your event, and whenever the health used to reduce or get up, you get notified in the blueprints via an event. And now we want to make our character clean, which means we have to use the component to handle. Now there is a $1 million question here. Should I create a component for every attribute? Absolutely not. So when do you need the component? The simple answer to this question is, if that attribute's value decides something for the character, then you create a component. Let's say if the health goes to 0, then you want to play a death animation. You want to destroy the character. That is something which you have to handle. There is some logic involved over there. Other situation like in Sekiro, if you kill a character once, you have to kill him again. There are always 2 to 3 lives that every character or enemy character has, right? So in that situation, you want to know whenever health drops to 0, that event is important to us. So whenever certain thresholds are important and you want to get notified about those events, then you go for components. But let's say if it's a stamina, now you are just draining the stamina, regenerating it, that's it, period, nothing else. So if something of that sort is happening, then you can just stick to normal attribute and just bind to it directly. There is no harm. Okay, whenever the character is involved or certain extra events are involved, then you go for the components to centralize the logic and to isolate it from the other places. Okay, but you just want to display it on the UI, nothing else, then you can just bind to the attribute directly, as simple as that, which we have done in the previous episode of the gameplay attributes. Now in this one, we are going to create a dedicated health component so that you can manage the values, you can get notified on certain events, and based on that you can do certain executions for the character. Okay, so first of all, let's go to health attribute set that is your uHealthSet.h. Let's create a constructor. Okay, and let's also define the attribute accessors that are coming from, let me first of all remove everything else. Yeah, that are coming from here. So how I will create the initer, getter, setter, and property getter for all these 4 attributes is using this function. So I'll go for attribute accessors. You have to provide the class name and the attribute name. So the class name is uHealthSet and the attribute is the health. And now you can create this 4 times for max health, damage, and healing. Okay, so now you have the attribute accessors, and let's also create the definition of this constructor and define the default health to 100.f and the max health to 100.f. Remember, this is not initializing, we are just defining the values. Initialization will happen later. So, okay, now we need to get our health component. So I'll go to Unreal and hit the live coding just to make sure everything is good. Okay, we need to include the ability system. There is an error. So let's include the ability system component .h. And let's also expose these 4 properties in the blueprints. I forgot to do for these 2. Oh, there is a typo in this. There should be property name. My bad. Let's hit the live coding again. Okay, we are good. So let's create the health component, and it is an actor component. It doesn't have to be pawn component because it is not going through any kind of life cycle. So I can select actor component and I will call it health component. And I will open this up. In the character, I will select this, create. Okay, so reload all. And you got your health component here. Now this is the component that will provide you the events to hear the health values. Okay, so now you are going to be dealing with the health attribute set. So first of all, you need that so that you can read the values. So you will go under the protected space so that the child classes can access it in case you derive. So T object pointer constant, and this time it's not a class, it's an object. So u health set, and I'll say health set. Okay, that means we have to include the class now. So let's forward declare it because we do not want to access anything from inside here. So u health set. Okay, so let's see. You need a function that gets you the health. So get health. It's a constant function because it is not going to modify, just going to read. Okay, and let's expose it to blueprints. Blueprint callable. Category health component, or just health would be fine as well. Okay, so you have the get health. You also need to get the max health because you know in games like almost in every game, Sekiro or Resident Evil 4, their max health get increased. Like in Resident Evil 4, you have to consume the yellow herb. In case of Sekiro, you have to gather a specific set of gourd seeds and give it to Emma. So we need to get the max health for UI as well. So get max health. Or maybe you just want to apply 50% of the max health, the damage or something like that. Then you need to get this. So one function is required here. And let me go and write it manually. Due to some reason it is creating in the character. So I'll just create it manually here. Get health. Okay. And then we need get max health. All right. So ternary operator or if else, whatever you like. So if the health set, if it is valid, then get the health. Okay. If it is not valid, then return 0.f. Fine. And it is supposed to be constant. You're not modifying anything. Do the same thing for max health. So get max health. And let's remove the stick component. Cool. Now we need to get this health set so that it gives us a valid value. Now here's a catch. This health set, first of all, let's initialize it to null by default. I will change the constructor to the object initializer one. We'll go back. Okay, you have done this before and this should not tick. Let's make it false. I will go into this tick use case in a great detail when we will have all the systems in place and we will see how to optimize. So I'll address this in a proper detail and what are the things that you should avoid. But in this episode, I really want to dodge it. So let's mark it false. That means it cannot take. Okay, so first of all, the health set, let's set it to null pointer. Okay, so the next question that arises, you are intentionally setting the health set to null pointer whenever this health component is created. Then who will give you the health set? Okay, that is the first question. And let's also include this health set class because you are trying to access a function from inside. So ability system health set.h. So now think about it. I told you pawn controller comes first, then the player state, then the player pawn, right? And then the player pawn is going through a life cycle, pawn extension and the pawn gameplay. Remember, pawn gameplay is the one who is initializing your ability system component. Are you able to recall? And the attributes, effects, abilities are connected with the ability system. So if the ability system is not ready, then you cannot access its attributes, right? So that means you have to wait till the ability system component is initialized, and only after that you will be able to access the attributes. Okay, so that means pawn extension has to tell you when the ability system is initialized. Remember, I told you in the last episodes when we were doing this entire setup that there may be another components that will require access to ASC or the pawn data, and in that situation they all will query through the pawn extension, right? So what we will do, we will go to our pawn extension component. You created a function initialize and uninitialize ability system, remember? If I scroll down, you see you were setting up the avatar actor. The owner was set in the player state. Remember? Initialize ability actor info. You were setting the owner and the avatar, and then the life cycle make the pawn extension in charge, and then it's set the avatar actor. Then we also handle the respawn situation. Okay. So once it is initialized, you would like to broadcast an event that, hey, the ability system is ready. You guys can access it and do your things. So what we will do, we will broadcast an event and everyone will bind to that event. Instead of continuously checking, they can just wait for that event. They don't even have to go through the life cycle. I told you it is not necessary to have life cycle in every situation. Okay, it's only for the initial load part. So I will go in the pawn extension and I will create an event dispatcher. Now in the blueprints, you used to go in the third person. If I go, for example, blueprints, base player, you used to create the event dispatchers here, right? Now let's do that thing in C++. So I'll create it under the protected space. I will say F simple multicast delegate because there can be multiple listeners, and I will say on ability system initialized. Remember, first you will set the owner, that will be done by the player state, and then the pawn extension will set the avatar. And these are the only two things that has to happen. And let's create another event dispatcher that is responsible for telling that the ability system is uninitialized. That means the character is dead, destroyed, or a new pawn has appeared. Then you will bind to that health component. Okay, that's a very crucial thing. All right, now let's also create two functions that will allow you to bind to these event dispatchers because you are not going to access them like this. So I will go in the public facility and I will create two functions. It's a void, not gonna return anything, just going to bind. So I'll say on ability system initialized, register and call, and you need to provide a delegate. I hope you guys are in sync with me. Remember in the tag manager, I told you to create this add tag listener, then you were binding and then you were attaching a delegate. It's exactly the same. Okay, so you need to provide a delegate. So it's a F simple multicast delegate, and let's give it a name delegate. Okay, then we also want to register for the on ability system uninitialized. So let's register for it. Okay, so you have the two functions. Let's create their definitions in the pawn extension. Okay, so first of all, if you are already bound, then we will not bound you again. So we will check if you are not bound. I'll say on ability system initialized dot is bound to the object, and we will get the delegate object. Okay, so if you are already bound, then there is no point. And if you are not, then add this delegate. Okay, so now we are accessing functions. So let's include this class. So we have to include the delegates. So include from the components. I'll just save some time here and we'll paste it directly. Okay, so you get the game framework component delegates. This is the pawn extension, which is a pawn component that is derived from the game framework. Remember, okay? So we are going to include this. All right. And if by the time you request to bind and the ability system is already initialized, then you would like to fire that immediately. So I'll just handle that small edge case here. If the ability system is already here, then delegate dot executes. Now this is an initial load edge case. This cannot happen in the uninitialized situation. So I'll just copy the first one. And this should be on ability system uninitialized. Let's go to health component. Okay, now the components will bind their event with this dispatcher and then it will be broadcasted. Now this is the usual thing that you should do. But I want you to think ahead of the time. See, this initialized and uninitialized will happen only once, right? And if you observe it more carefully, when the game starts to load and the player comes into the picture, the ability system component will be initialized. That is the first occurrence. So technically, only once in the lifetime of the character it will be called. So now imagine if just for one occurrence, will you bind all the components? That is a question. Okay. So standard way would be every component binds to it and then unbind it. That is little overwhelming. What you can do is that let character bind to it, and when you broadcast, the character will inform all the other components. It will be much cheaper and simpler. So what we will do, we will go to our base game character, which is the original file right now. First of all, I need to add the health component here. So I will create a private space and I'll copy this and make this u health component, and I will say health component. Okay, and let me forward declare this class, and I'll go to base game character.cpp. We are creating pawn extension. Let's also create the health component. So health component is equals to create default sub object health component. Okay, now we have to include the class. So include dot h. Okay, now what we will do, when the ability system component is initialized, the character will be informed and it will inform all the components. So we will just create a function that the ability system is initialized. Please initialize yourself or do the initialization work. So what I will do in the base game character, under the protected space, I will make an overridable function so that if you derive other enemy, base enemy or like that, you can still use it. I will say virtual and void on ability system initialized. Okay, and I will do this for uninitialized as well. Now let's create their definitions. Now here you can call the health component and inform it that the ability system has been initialized. This is much cheaper because you are just making a function call. So let's make that function in the health component. Under the public, we will say void initialize with ability system in case later you do not have the possibility, some scenario where the ASC is not valid and you would like to go for normal approach, then you can have the function and call that as well. At this moment, we are considering ASC will be present. So our ability system is the base ability system component. So let's forward declare it. U base, let's forward declare it on top and write it input ASC. Okay, let's expose them to blueprints as well. Create another function for uninitialize and let's expose it to blueprints as well. Now let's create the definition. Okay, now the function is available. We can go back to character and access this initialize with ability system. Okay, now you need to pass the ASC. So we need to create a function that can give us the ASC. And along with this, I told you we used to get this ability system component from here. But if you talk about the components, let's say the tag manager that we had earlier, you used to call the get ability system component. Now this was coming from the interface. You see, will use ability system interface, and then you used to pass the actor. So we need to override this function as well, so that in case in the blueprints, if you query with this function that comes with the ability system interface, it should give you a valid one. So we will handle both the situations. One is to get the base ability system component. Second is to override that interface function. So I will go here and I will add that interface. So it's a public I ability system interface. Okay, let's include it. Ability system interface.h. Okay. Now it's a public function, that's why you are able to call everywhere. So first of all, we will override the interface one. So what was that? Get ability system component. So get ability system component. It should not be void. You have to return the ability system component. And this will be the original class. Okay. So the U ability system component. Okay. It's a constant. It's not modifying anything. And the ASC is stored in the pawn extension. So we will get it from there. And we will create a function for ourselves that is to get the base ability system component, so that we don't have to cast over from where we are calling. So void U base, also make it pointer, and get the base ability system component. Constant again, not modifying anything. Let's forward declare it. Let's also forward declare the ability system component. Okay. Now let's create this function and we are supposed to override it. So override. Let's create the definition. Oh, why am I writing void? My bad. I'm really sorry. Okay. Okay. And this get ability system component should be available in the blueprints because it is part of the interface. So blueprint callable. And this is for our internal use. Let's go and create the definition of base ability system component as well. So in the normal ability system, we will just get it from the pawn extension. So if the pawn extension is not ready, then we can't help it. So if pawn extension is not valid, return null. But if it is valid, then call the function that is present in the pawn extension, that is to get ability system component. And we will call this function so that we don't have to do this again. And I will just cast. So what I can do is just return cast, and the class is ubase ability system component. Okay, so now you have the ability system component with you. That means you can inform the other component. Now this is important because if the ability system is not there, then the components will not work out, HUD will not work out, other features will not work out. So you have to check. So first of all, get the base ability system component and u base ability system component ASC. Ensure that the ASC is valid, because if it is not valid, then crash. We have to look into it. More importantly, you have to include the ability system now. So include ability system base ability system component.h. Okay, so your errors are gone and now you can inform it. And let's also uninitialize it. So I'll say uninitialized from ability system. This was the function name. Okay. Now let's do it here. In the uninitialized case, first of all, we need the health set to be null pointer again. And now when the initialize with ability system is done, we have to bind. Okay, so everyone will bind to you and you will bind to the attribute. So first of all, you have to bind with the attributes. So let's create a function so that you can bind to it. So under the protected space, you will bind to that attribute. But that attribute also has to provide you the feature so that you can bind, or basically the event dispatcher. So this situation can happen with any attribute because eventually everyone has to bind to that special attribute based on their requirements. So in the base attribute, we will create a event dispatcher structure so that everyone can inherit. Let's go to attributes, base attributes set.h. Remember, first you are trying to bind to this attribute so that as a health component, you can receive the changes and then you will broadcast to others. Okay. You are not allowing other components or other features to directly bind to the attribute. That is something we are avoiding. Okay, so I'll say declare multicast delegate and we will accept 6 params. Okay, so first is, let's give it a name, f base attribute. So first is the instigator. Remember, you are just declaring, you're defining. If you remember here, you were defining the signature, what are the pins will be there. So just like if you select this, you can define the pins like this, or you can copy the signature or the structure, input structure from another event. So that's what you are doing here. You are declaring, you are not defining. Remember in the gameplay tags as well, I'm trying to relate everything so that you can connect what you did. If I go to public, you were declaring. In the CPP, you were defining. Okay, so we are just declaring so that every attribute set will have this event dispatcher so that everyone can attach to it. So the effector instigator, then we have who caused it. So then we need the gameplay effect spec. Remember, attributes are modified through the gameplay effect. So we need the effect spec. Then the magnitude, so it will be of type float. Then we need the old and the new value. So, okay, so you have the 6 param and let's forward declare this f gameplay effect struct. So struct. All right, so we are good. Now you can bind to it. So let's create a function that we will bind. So in the protected space of the health component, virtual void handle health changed. I'll just save some time here. Okay, so you got all the input pins: damage instigator, damage causer, damage effect spec, damage magnitude, old value, and the new value. And same thing, you also want to track for the max health changed. So you have two functions. Now you can bind them with the gameplay attributes. So first of all, you need the health attribute. So for health attribute set, you have to get it from the ability system. And for that, we had to ensure that the ability system is ready. So that's why we created this function. So now the ability system component is valid. We have to get it. So let's create a function. And I believe that every attribute will require it. So let's go to base attribute set.h and let's create a function here so that everyone will have access to it. So let's make it public. Base ability system component star get base ability system component. Not modifying anything, constant. And let's create its definition in the base attribute set.cpp. How do we get it from the attribute? That is, whoever owns this particular attribute set class get that ability system. So you will use, first of all, let's include the class. Now you can get owning ability system component. Now this will give you the ability system component. You have to cast it. Now this function will be available in every attribute set. Okay, first of all, let's ensure that the owner is there, because if the owner is not there, then the initialization has no point. When I say owner, that means the avatar actor. So get owner, it's an actor component. Remember, it's no longer get pawn, it's owner because it's an actor component. Owner, check if it is valid or not. Okay, now if owner is valid, then only proceed. Now, will it have ability system component ready? That is not guaranteed. So we will consider that as an exception. It is not something we are going to consider as a breaking point. So if the input ability system component is not valid, return. Let's say you are a pawn, you are repossessed, or you possess some vehicle or something else. That does not mean you will re-initialize the entire health attributes and all that. So that means we have to do this only once. Okay, so this means that we have to store a reference of this, because we want to make sure that we are using the right ability system component. See, if you are possessing a vehicle, you will not want to create another ability system component. You will just grab the attributes of that vehicle to your ability system, because under the hood it is all about attributes. If you are in a tank, your health gets 1000, so you don't have to create a new ability system just for getting 1000 health. You can just add into you as long as you are in a possession. As soon as you unpossess it, you remove that effect and you are back to your 100 health. Okay, so that is the idea. Reuse the character's ability system component for all the possessable pawns, that is your vehicles and other stuff. So what I will say, u property t object pointer, it's a u base ability system component. This is the component that is being used by this health component, the object that you will create. Okay, so let's copy it, and I think we already have it, so fine. Let's initialize the ability system component to null by default intentionally, and here we will store it for the first time. So first of all, let's ensure that we don't have the ability system component, because if we do have it, then we are not reinitializing ourselves. So if the ability system component is valid, then return, because we are already initialized. But let's say if you are not, then we will check if this is valid or not, the incoming one. So if the input ASC is not valid, then it is not ready. Now we know, so we will save it. Okay, now you can get the attribute set. So ability system component, get u health set, and let's save it in the health set variable that we created. Okay, now you have the health attribute set. And now since we are accessing a function, we have to include the ability system as well. So include ability system base ability system component. Now if this health set is not valid, then we cannot proceed. That means simply the health set is not there. So it's a pointer check, so we have to do it. You can also add a log. Okay, now before we bind to the health attribute, let's first complete our flow that is ongoing, that is in the base game character. So you see, as soon as the character is informed that the ability system is ready, it will call the health component, and the health component will be prepared, and it will get the health attribute set, and it will bind to the health attribute so that it can receive the change in values that will be done by the gameplay effects. So the character has to be informed, and for that character has to bind to the pawn extension so that pawn extension can tell it. So we have prepared our functions to register. Okay, so I'll go to base game character. Right after the pawn extension is created, I will go pawn extension component on ability system initialized, and we have to prepare the delegate. So it was f simple multicast delegate, and from this I want to get the delegate, and I want to create u object, and now you have to provide this, and we have to provide the function that has to be called. So reference of that function so the reference of the function that is part of this class, that is your base game character, and the function name is on ability system initialized. So let's paste it here, and let's also register for the uninitialized. I will go for pawn extension component on ability system uninitialize. Same thing which we did here. So I'll just save some time here. We have to go for on ability system uninitialized, which is right here. Okay, great. So now you have binded to it. I will go to pawn extension component. Right after the ability system is initialized, I will broadcast the message. So I will go on ability system initialized dot broadcast. Okay, and we have to call the uninitialize as well. So let's call it on ability system uninitialized dot broadcast. Remember, uninitialization is considered when the avatar and the owner are the same. Then only we consider it as a valid uninitialization. Otherwise, it's just a garbage. And there is an error. So let's see. Oh, it's a event dispatcher, and you are not supposed to call it as a function. So remove the parenthesis. Okay, so your errors are gone. So now it will inform the base game character, and the base game character. Okay, there is an issue. This is a private component now, so you have to use the meta allow private access like I told you. So meta, great. Okay, let's compile this much. If you have your project open, you can hit the live coding. I closed it, so I'm going to build again, and there is an error. Let's see. Okay, we have not included or declared the ability system component, so let's forward declare it. And here in the health component, we have to forward declare this one as well. We are using this struct. So let's forward declare it. And there is some error in this. Oh, okay. The I should be capital, uninitialized. Okay. Let's also correct here. It should be uninitialized. And there is a error regarding cannot access private member in the. Oh, okay. This toggle crutch should be public. So let's mark public here. Okay. So everything is fixed. Now let's revise. The pawn extension will fire on ability system initialized event right after when the life cycle is done. Then in the base game character, it will hear and will fire this function on ability system initialize. This will inform all the components. That includes our health component, which will then initialize with the ability system component, which means it will bind to the health attribute set. So now we have to bind to the attributes. Let's do it. So let's open the health attribute and base attribute. So you have declared this, and now let's use it in our health attribute. So we will go to our health set.h, and under the public, I will say mutable f base attribute event. That is what you created, right? This one. So we will use this, and this will follow the exact same input structure, the signature you made, and we will call this one on health changed. Let's create two more, on max health changed and on out of health. Okay, these are the three important events that you want to know. So with this, you will be able to receive the changes in the health component, and from there onwards, you can broadcast or share it with anyone, whoever wants to bind basically. So we will do this in the next episode with the gameplay effect and their calculations so that you can relate. I think we have already crossed the time limit of this episode, so I have to push it in the next one. So let's go to our health component. These two functions that we created, let's create their definitions. Okay, and we will bind these two right here. So I will say health set on health changed dot add unreal object, and the function that we want to bind from this class, let's pass its reference, handle health changed. Okay, and copy this, do it for handle max health changed, and change this one to on max health changed. Okay, there is one more that is out of health, for which we have to do the death animation and all that. I will consider that in the next episode. And okay, so you hear from the attributes, and then this function will be called, and this will broadcast, and the HUD and the player will listen to it. So you have to provide a event dispatcher as well. So I'll go to health component. Remember, everyone is going to connect through this health component, not to the attributes. Okay, only in the exceptional cases or the internal use you can directly connect with them, just like the health component is connecting. But for the blueprints, they are going to talk through the health component. So for that, we have to give them the facility. I will go under the public, and again I have to declare the structure. So declare dynamic multicast delegate, 4 parameters, that is f health attribute changed. This is the event name or the event dispatcher's name, and here you can pass the parameters that you want to give. So first would be the health component. So let's pass the health component. Then we have to pass the old value, so it is of type float, and I'll say old value. Then I have to pass the new value, so float comma new value, and the instigator, so the actor pointer comma instigator. Okay, this is the information that you will receive. So let's follow this structure. So f health attribute changed on health changed. Okay, this is the name, and let's copy this and do it for on max health. Okay, and we will mark them blueprint assignable. So u property assignable. Okay, let me break it down so that you can read it easily. Remember, this pointer is together. So we will fire this. We will go and we will say on health changed broadcast. Okay, so the first is the health component, so this one, and then you have to pass the old value, new value. So pass the old value, new value, then the instigator, so the damage instigator. Okay, and let's copy this, paste it here. That is for max health change. So it's a full chain of events. Okay, it's not like everyone is connecting through the attribute now. So I will play. Okay, so our project is up and running. We will go to our base player and you will see the health component, so you can get it. And now you can bind the event to on health change, and when you will do custom event you will see the structure. Okay, it is absolutely similar to what you did with me in the gameplay tag manager in the episode 6 and 7. So I hope that experience is now benefiting you, and if you find it difficult to understand, I highly recommend you revise that and come back here. All right, so that's it for this episode. I hope you guys enjoyed it. Do let me know if you have any doubts, queries, or suggestions or feedback. Feel free to reach out, and do not just copy paste the code. Try to understand. And more importantly, if you're just following in middle of the series, then I definitely agree that you might be feeling dizzy in between the episode. So I would highly recommend that first of all you check out episode 6 and 7. We made this exact thing, the event dispatchers and binding and delegates, all that in pure blueprints. Okay, we have just did the same thing in C++. The second part is the attributes. I have already created one episode purely dedicated how to set up the basic attributes. Now we are just advancing and enhancing the system to support our game in a AAA style. Okay, so if you're just directly following without any foundations or without having your concepts cleared, then it might be difficult to follow along. I'm not expecting anyone to follow, because if you are not ready, you are not ready. You should just revise the old things. Maybe reach out on Discord if you have any sort of confusion. I'll be happy to answer them, but just don't copy paste it, because otherwise you will not make it in the later episodes, which will get little more sophisticated, not complex, sophisticated, because we will consider a lot of aspects. Because AAA games look really easy to understand, but when it comes to developing their communications, there are a lot of layers, and I don't want you to get lost. That's why I created these little episodes earlier, so that you can have some foundation when I'm doing this advanced stuff. Okay, so if you like my work and you want to support me, the Patreon and the coffee link is in the description. The code files are also available in the new Patreon tier that is available. You can check that out. But all the assets that are used in this series, including the characters, animations, and other 3D objects, they are absolutely free. You can download them from Discord. So I'll see you in the next episode. Till then, you take care. Bye bye.